Hi, this is Mrs. Vaughn, and I want to give you a lesson on inscribed angles. The inscribed angle is an angle formed by two chords that has its vertex on the circle, okay? Versus in the circle where we had our central angle. If you had a vertex at the center of the circle and you went out, this is your central angle. And now we're talking about the inscribed angle. Okay, do you notice how the inscribed angle is smaller than the central angle? Okay, well, we know that our intercepted arc and our central angle have the same measurement, where the inscribed angle is going to have a smaller measurement. As a matter of fact, the inscribed angle measure is half of the intercepted arc. The inscribed angle equals half of its intercepted arc. Okay, so I'm going to erase the central angle, and we're only talking about the inscribed angles now. So inscribed angles are half of the intercepted arc. Remember that the intercepted arc is the arc that's on the interior of your angle. So it's the part of the circle that measures in degrees, okay, and it is on the interior of the angle. So the arc is twice as big as the angle, and the angle is half of its arc. One of the theorems that inscribed angles have is that if you have two inscribed angles, two angles with their vertices on the circle, and they go and intercept the circle at the same arc, then they have to be congruent angles. For example, if this intercepted arc was, say, 50 degrees from here to here, and we wanted to know what what the two angles were, we would know that this intercepted angle is 25 because it's half of the arc, and so is this one, is half of the arc, which is 25. And so that means these two have to be equal. Another example that I can give you is, say I gave you that one of the angles was, say, 15. Okay, and I asked you, what is x? What is the measurement of the other angle? Well, because you know that this green angle is 15 degrees, then you know its arc is going to be 30 degrees. And therefore, now we know that x is going to be half of 30. So x is going to equal 15 also. But because of this theorem, we don't even have to figure out what this arc is. We can just go straight, oh, they both intercept the same arc. So we know that they have to be congruent or equal measures. Okay, so sometimes we have inscribed angles that intercept a semicircle. So I noticed that I put a diameter right here. That way you could see it went through the center. So this is exactly half the circle. So this 180 degrees is exactly half the circle, and this angle, this inscribed angle with its vertex on the circle, intercepts that semicircle. So it has to be half of 180, and that would be 90 degrees. One of the problems that I'm going to give you is what would be the measure of this angle right here. If you know this is x and this is 2x. So I'm going to, so what would x equal? Okay, so what do you know about the angles in a triangle? Well, all the angles are going to add up to 180. Okay, So I can write, if I subtracted 90 from 180, I get 90. And so 90 is what those two angles right here and here are going to add up to. So we get 3x equals 90, and therefore x is going to equal 30 degrees. The last theorem that I'm going to tell you about is if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. And so what we have here is the quadrilateral, that's a four-sided figure, and all four angles or vertices of the quadrilateral are on the circle. So each one of these is an inscribed angle. Okay, so what this theorem says is that the opposite angles are going to be supplementary. So angle A plus angle C is going to equal 180. That's what supplementary is, two angles that add up to 180. So angle A and angle C, they're not necessarily the same. In this picture, they look like they are, but they will always add up to 180. So will angle B plus angle D are going to add up to 180. If you notice that angle A intercepts this arc BCD, and angle C intercepts this arc BAD. And they make up the whole circle. So if I had this arc plus this arc, they add up to 360, and each one of these angles is equal to half the arcs. And so if I added up half of one arc and half of the other arc, I take half of 360 and I get 180. So the opposite angles are supplementary. Opposite angles are supplementary whenever you have a quadrilateral four-sided figure inscribed in the circle, which means all four vertices are going to be on the circle. Okay? Let's just go over what we just did. All right, if you have two inscribed angles that intercept the same arc, they are congruent. So I have two inscribed angles. So here's my circle, here's one inscribed angle, here's another inscribed angle. So they both intercept the same arc, so my two angles are congruent. Next, an inscribed angle that intercepts a semicircle is a right angle. So here is my circle, here is a diameter which marks half of the circle. So if I draw my inscribed angle to intercept the semicircle, then I know I have to have a right angle. And last, if a quadrilateral is inscribed in a circle, then its opposite angles are going to be supplementary. So this angle is opposite of this angle, and so those two would add to 180. I hope this helps. Thanks for watching. Mrs. Vaughn.